There are a couple of ways that polynomial division and synthetic division are used to find zeros of polynomials. The first is just using synthetic division to identify zeros. So that means if we already have a value that we think might be a zero, we can use synthetic division to verify. And it's based on the idea that if we get a remainder of 0 upon division by x minus k, then we would say that these polynomials divide evenly. If they divide evenly, that means that x minus k is a factor of the function. And the factor theorem then tells us that means that k is a zero of the function. So we're going to use synthetic division to answer this question. -1 is our zero. And the polynomial coefficients, notice that we do not have an x to the 1 term in this polynomial, so remember that we need to replace that with a 0. Our polynomial coefficients are 2, -6, 0, and 10. Also recall that in synthetic division, whenever we're going down, we just add, or in this first case, we just drop the first number down, and that whenever we are going diagonally upwards, we multiply by k. So in this case, going diagonally upwards, 2 times -1 gives me -2. As I go down, I simply add. So -6 plus -2 gets me -8. I then go again diagonally up. -8 times -1 is +8. And I add 0 plus 8 gets me 8. Going diagonally up again, 8 times -1 is -8. And I add downwards to get a remainder of 2. Because my remainder is equal to 2, not 0, these do not divide evenly. So I would say no, that in fact -1 is not a zero of this function. The other way in which we use synthetic division is a bit more important, because there were other ways that we could have figured out whether -1 was a zero. We could have simply plugged it in and seen if we get 0 as an output. The reason we use synthetic division is that sometimes the computations are easier because we don't have to raise to a power. This is especially true if you have a fraction that you're trying to check, and because if it does turn out to be a 0, we want to use the result of division. The quotient that we get from that synthetic division will be useful in the next step. So what we're looking at with this question is the next step. We're saying given that x minus 2 is a factor, so let's say we've already established that part, we're going to find the complete factored form of f, and looking at this function f, we can see that it's a degree 3 polynomial. We really don't have traditional high school factoring methods that will apply to this. So what we're going to do is use synthetic division. If x minus k is the factor, then k is the 0, so k in this case is equal to +2. I'm going to use synthetic division with +2 and the coefficients of this polynomial to find out what I have remaining after dividing by x minus 2. So a quick synthetic division here gets us, we verify that the remainder is 0, which we expected to happen because we were told that x minus 2 is a factor. So that was my remainder. But what I really want is the quotient. And the quotient is what I get from these numbers, associating them with the correct power of x. So the remainder, next we have the constant term. I'm going to write that as a c. It's like x to the 0. Then I have my x to the 1 term. Then I have my x to the 2 term. So that these numbers make up the polynomial 3x squared plus x minus 2. This is the quotient upon dividing by x minus 2, so that's another factor here, x minus 2. So by performing division here, I have started the process of factoring this degree 3 polynomial. I haven't finished. I have some more work to do, but the reason that was an important first step is that it got me down to now a product of a degree 1 and a degree 2. And degree 2 polynomials we generally do know how to factor by other methods. You could do the trial and error method here, which is what I would recommend. You could try the 4-term grouping method if that's something that you're familiar with. You could even use the quadratic formula if you wanted to find the zeros from that and then back out the factorization using the factor theorem. I'm going to go ahead and use the trial and error method here. I know that that's got to be a 3x times x that gets me the first term 3x squared. I know that last term has to come from 2 times 1. I can see that putting the 2 with the 3x term is going to keep that middle term from getting too big. So now I just have to figure out the signs. It looks like I want a plus 3x, so plus 1 times 3x, and a minus 2x, so minus 2 times x, to get me the correct middle term. Now I have the factored form of this polynomial, which I can go ahead and write under factored form of f. X minus 2, 3x minus 2, and x plus 1. And because I was able to factor it, I can find the zeros of this just by setting each factor equal to 0. X equals 2 is my first 0. 3x minus 2, setting that equal to 0 would eventually get me x equals 2/3. And x plus 1 would get me x equals -1. So that my zeros corresponding to each of these factors are 2, 2/3, and -1. So let's try this process again. This problem isn't going to come out exactly the same as the one we just did, but we would still start the same way. We don't know how it's going to end up, right? We still are given a 0, this time given a 0 instead of given a factor, but it's really the same thing. So this tells me that k is equal to 1/2. Since we're given the 0, not the factor, there's no changing of sign in between this time. And then we're given a polynomial. So let's go ahead and start the synthetic division. Dropping down the 6, multiplying 6 by 1/2 is like dividing 6 by 2. So I see that I get 3. -11 plus 3 is -8. And again, dividing -8 by 2 gets me -4. Adding downwards gets me -8 again. Dividing -8 by 2 gets me -4 again. And adding downwards gets me 0. Again, this is not a surprise. We were told that 1/2 is a 0 of this polynomial, so this part should happen, the remainder equal to 0. And now to build up my quotient, I have a constant term, I have an x to the power 1, and I have an x squared term. So that gets me the polynomial 6x squared minus 8x minus 8. I'm going to factor this. I also still have the factor that comes from this 0. Just using the factor theorem, this was really x minus 1/2. Okay, so now I'm going to start working on factoring 6x squared minus 8x minus 8. The first thing I notice about this is that it has a common factor of 2 that I can remove. So I'll do that first. And then I'll look at this resulting polynomial and see if I can factor it. This also factors using trial and error pretty easily. if our first guess is just to put 2 and 2, because 2 times 2 is 4, then I can see my outer and inner terms are going to be 6x and 2x. I want the 6x to be negative and the 2x to be positive in order to get me the correct middle term. So let's go ahead and put all of these factors together for my factored form. I'm going to put the 2 first because, again, it's a single term factor. So the monomial factor generally comes first. And then my x minus 1/2. And then the 2 factors that I just found, 3x plus 2, x minus 2. Now, something worth mentioning is that there often is more than one way to write a factored polynomial. And if we look at this first part here, we have 2 and we have x minus 1/2. Generally, it's the case that if we found a factor by synthetic division, that k, right, if we found a factor by guessing that k and using synthetic division, it's going to be in the form x minus k, even if that results in a fraction term. So if we have a fraction in our factor, somewhere we're going to have a number multiplied on the outside to compensate for that fraction. What I mean by that is, if I were to multiply that 2 into the parentheses and just distribute, I can see that what I get is 2x minus 1. So it would also be okay to have this whole factorization written as 2x minus 1 times 3x plus 2 times x minus 2. And which form you get really just depends on what order and what method you used to find those factors. Anything you find by trial and error is going to look more like these. And factors that you find using the factor theorem and synthetic division might end up looking more like this, right? Like a number multiplied on the outside and then all of your factors starting with just x. They don't come out starting with something like 2x or 3x if we found them using the factor theorem. So just realize that both forms are correct and that you might do a problem 2 different ways and end up with the 2 different forms just because of the order in which you found those zeros. So now looking at these factors, we can find the zeros corresponding to them. We already know that we get the 0 1/2 from this first factor. We can then look at these other 2 factors and set them equal to 0. This would get us x equals negative 2/3. This last one would get us x equals positive 2. If you can't look at these factors and see that right away, just set them equal to 0 and follow the process, right, of solving. We would first subtract 2 from both sides in this case. We would then divide both sides by -3, which is the coefficient of x. Sorry, by 3. And that's how that negative 2/3 comes out. After doing this enough times, most of us find that we don't really have to follow that whole process because you can look at these 2 numbers and make a ratio out of them, and you can recognize that the sign will change in the process of solving for x. So that would be our final answer.